All right, so in this lesson, we're going to be talking about the seasons, and we're going to be reading through the seasons, checking our engage section here in our notes, and then also getting started on the explore section. So within OneNote here, you should have, started the seasons here. Now, if you haven't, that's fine. We're going to be talking about it together as well. So the first thing we're going to be looking at is the seasonal changes depend on where you what. So let's go ahead and get started. So reasons for the seasons. So you're celebrating a winter holiday with your family. You've been outside all day, but now the sun is setting. It's early, but that's normal for this time of year. It was cold all day, but now the temperature is dropping even more. I'm freezing, you say, and head indoors. The television is on, and you stop to watch a live broadcast of a celebration in Brazil. There, everyone is enjoying a warm late afternoon at the beach. The sun is still out, the people are wearing summer clothes. What's going on? So, in the videos below, you can watch this on your own. You'll learn about the cycle of the seasons on a prairie in the northern hemisphere, similar to like where we are here in Indiana. So, what do you think is happening on the southern hemisphere at the same time? So, you can watch this video on your own, but we're going to keep on going. What are the seasons like where you live? What changes do you notice in the weather? Does it stay light outside much later in the summer than in the winter? Well, some seasonal changes depend on where you live. For example, you might notice more changes if you live farther away from the equator. This is exactly, guys, what we just were looking at with our temperature graphing that we did in the previous activity, the northern versus southern hemisphere graphing. So in this lesson, we'll learn what causes seasonal changes. You will investigate how the position of the sun and other stars change during the seasons, and we'll also discover why the seasons are different in the northern and southern hemisphere. So let's jump to our notes, and we can do this engage section here, the one that we started with before. So first off, when we look at our world picture here, it's important to notice that we have our northern hemisphere, that's the top half, and then we have the southern hemisphere at the bottom. Now, what separates that is this imaginary line that goes around, and this is the equator, right? So, if we were thinking of the further you go up from the equator or down from the equator, we have bigger changes the further we go. Bigger changes. Now, if we are staying right along the equator here, we have similar or less changes and that's with our temperature. So let's look at our notes here. So seasonal changes depend on where you live. The further you are from the equator, the greater the change. So the farther away you are from the equator, the greater the change that you will see. Now, the position of the sun and the stars. If you've ever looked out at the night sky like here in October, it's one image of our night sky of where the stars are located. But if you were to look at that later on in March or April, you'll notice that those stars are not in the same place. And so that is, we'll notice how they change during the seasons. We'll talk about that during this unit. So different seasons are there for northern and southern hemispheres. And so if we were to look back at our graphing here, if we were to identify how the temperatures appear in our northern hemisphere, what we call June, July, August, in this little window here, this is what we call summer. And then we have winter at the other ends, right? And then in between that, we'd have spring and fall between each of those. And so that matches kind of what we see here during our normal year. That in the winter it's really cold, in the summer it's really warm, and then it gets colder again as the year progresses. But if we were to look at the southern hemisphere here, we can notice how the temperature here in June, July, and August, this is the colder part. This is their winter, which means that then we have summer in January, February, and December. The temperature is warmer here. And then between them, we have, so summer to winter, this would then be fall. And then winter to summer here, this would be spring. So if we compare the two difference, these seasons are opposite. The temperatures are opposite. Summer, it's really warm in the northern hemisphere. This is us. That's why it's summertime in June, July, August. In the southern hemisphere, in June, July, August, it's much colder. So that's their winter. And it's all dependent on the tilt of the earth. All right. So let's keep on going and talking about our notes and read in a little bit more on how does Earth move in relation to the sun. So jumping back to our notes. Well, I guess let's keep on going here. So what do we know about the seasons like this? Well, drag the line for the diagram of the Earth's axis. Well, the Earth's axis, the tilt that the Earth spins on, it doesn't spin horizontally. That would kind of look more like the equator. This vertical line here, yeah, we do have a northern pole, a north pole, and a south pole. They are on top of each other, below each other here, but the Earth is tilted. So if we were to plug in our axis that's tilted here, that would better represent the tilt of the Earth. And then during which month does North America receive the most solar energy? Well, the most solar energy, we need to think about that. Solar energy, we can think of it as temperature, of thermal energy, right? So North America, that's us. So which month do we receive the most thermal energy, the most solar energy? Well, that is going to be July compared to all of these. Sure, it may be a little warmer in April, but that is our springtime for North America. So we haven't received the most. It's always the warmest in July compared to the rest. All right, so let's go back up and let's start talking about the Explorer section. Remember, this is like the meat and potatoes of the lesson. So we won't get through it all, but we'll definitely get through a good chunk of it right now. So how does Earth move in relation to the sun? Well, looking at our notes. So the Earth, what? On an axis. So we need to think about, well, what would we fill in there? All right. So let's jump back to our reading and start. So have you ever spun a globe that was attached to a stand? Well, the globe spins around its axis, which is an imaginary line running from between the north and south poles. So that is an important thing, that we spin on an axis, and that's an imaginary line. There's really not like this metal rod going through the middle of the Earth. All right. So Earth actually spins the same way. Earth makes one full rotation, or a complete spin, around its own axis every 24 hours. One rotation is what we call the day and night cycle. So 24 hours in a day. So 24 hours for daytime and nighttime, just not like day. All right. So it's day when we're facing the sun, when Earth is facing the sun, and it's night when we're not facing the sun. And that's helpful because it's really hard to sleep when it's really light outside. And the sun gives us two things, heat and light. So it's helpful that Earth rotates because that divides each 24-hour period into day and night. And we talked about this before when we were reading in on the star, our star, the sun, and how the Earth kind of has this built-in air conditioner. And so it gives us time to be active and sleep, but also it keeps temperatures from changing too much. During the night, Earth's surface will cool because the sun isn't shining on it to continue to heat it up. But before it gets too cold, Earth's rotation will bring daylight and warmth from the sun again. Before it gets too hot, well, it continues rotating and brings nightfall and cooler temperatures again. So we rotate on this axis. So let's jump into our notes and fill in some of those details there. So the Earth spins, or we would say that it more properly said, it rotates on an axis. And that, again, is an imaginary line running between the North and South Pole. Now, one full rotation, right? These are the same thing, rotation on its axis. It takes 24 hours, and that is a day and night cycle. Well, it's day when we're facing the sun, and then the opposite of that, well, it would be night when we're not facing the sun. And this important rotation helps control temperature. All right. So that rotation, day and night cycle, helps our rotation, or that rotation helps our temperature being controlled properly. Now, Earth doesn't just rotate on an axis. It also revolves around the sun. Oh, revolves, right? So when we revolve, right, that means that we are also moving in another way, right? So Earth makes one full revolution, a revolution, right? Like if you were like to go against something, you revolt. No, the Earth is not revolting against the sun, right? But it does make a full revolution or a complete loop around the sun every 365 days or 1/4 day, right? So we call this journey 1 year. So you probably know that there are 365 days in a year. These days are shown on our calendar. But what about that quarter day, right? And that quarter day, because it takes 365.25, right? A quarter is 25 cents. We need 4 quarters to make $1. Well, over many years, that quarter day could really shift the calendar, right? So if we didn't add up those quarter days, we would eventually have, in the Northern Hemisphere, our seasons would flip. We'd eventually have winter in the summer time and summer in the winter time. Or like our seasons would flip, like with our Northern and Southern Hemispheres. So we correct for that change with leap years. And you're probably familiar with leap years because those happen every 4 years. Remember, 4 quarters make $1. So every 4 years, we add an extra day. And at the end of February, we take that extra day, and that's where every 4 years we get February 29th. So if you had a birthday on February 29th, you'd only have 3 birthdays by the time you turn 12. So for you guys, if there's anybody that has a birthday on February 29th, right now, you very well may be only 2 years old, right? But I will still, accept you in our class. You're still part of everybody. And many people that have a birthday on February 29th on Leap Day, they more likely celebrate it on February 28th. Just because it's still part of February, but obviously it's all dependent on their calendar schedule, right? No pun intended with a calendar schedule and their birthday being on Leap Day. All right, so let's jump back into our notes and fill in some more details there. So while rotating, Earth also revolves around the sun. So this movement going around the sun, this green line here, is what we call it revolves. All right, but the Earth itself here, right, there's this little bit here. That is where we rotate, right? So the Earth rotates, it spins, but while it rotates and spins, it revolves, right? So one full revolution, right? One full revolution or a complete loop or orbit around the sun is 365.25 days. And that is what we call a year. But that 0.25 that we see here, that 0.25 adds up, and that's where we get our leap day, and that occurs every 4 years. All right. So take a moment and catch your notes at that point. I'm going to keep on reading. Well, let's watch a quick clip here. Or you can watch these clips on your own. But what causes seasonal patterns in different parts of the globe? So, did you know that Earth's axis is tilted? In fact, Earth's axis is tilted at 23.5 degrees. Now, that degrees does not mean temperature degrees. That's an angle degree. This angle does not change as Earth orbits the sun. Earth's tilt causes different parts of the planet to receive different amounts of sunlight throughout the year. When one part of Earth is tilted toward the sun, we say that it's summer in that hemisphere. So if you live in the northern hemisphere, you probably enjoy an increased sunlight during your summer vacation. And then during the winter, the opposite is true. The northern hemisphere tilts away from the sun and receives less direct sunlight. And less direct sunlight means that we get less thermal energy, which is why during the winter, it's cooler, it's colder. So in our notes, Earth is tilted on an axis, and it's 23.5 degrees. So this tilt causes different amounts of sunlight on Earth, causing our seasons. And this, ladies and gentlemen, is what I've been saying. The tilt is the reason for the seasons, right? Tilt is the reason for the seasons. So when the hemisphere is tilted toward the sun, that means that it is, let's get rid of that line right where I'm going to write, that line, or the hemisphere tilted toward the sun, when it's tilted to the sun, it means that it is summer. And the hemisphere tilted away from the sun then means that it is winter.